बिल्कुल दोस्त, वेलकम टू दिस कॉम्प्रिहेंसिव इंजीनियरिंग एक्सप्लेनर। आज हम एलडी, एफबीडी, एसटी और एसएफसी को कब, कहाँ, क्यों और कैसे चूज करना है को प्रैक्टिकल इंजीनियरिंग डिसीजन के फॉर्म में लॉक करते हैं। वी आर गोइंग टू कंप्लीटली ब्रेक डाउन द 2025 PLC language landscape, and trust me, it's pretty fascinating.
Okay, let's dive right into this. You hear this question literally all the time on the plant floor, right? Which language is the best? But right out of the gate, we need to challenge this industry misconception. The idea that automation engineers absolutely must pick a single winning language to learn and use for every single problem, it's completely outdated and frankly just incorrect.
To really master modern automation, we need a massive paradigm shift. Teen inhe four competing languages matsamjo. Instead, you've got to understand that these are four distinct, completely complementary engineering views of the exact same control system architecture. It's like looking at a building's blueprints, you know? You have your electrical, plumbing, and structural views. They all describe the exact same building. They just highlight different critical aspects. Real projects may multiple approaches combine key jasakti, and that's where the real magic happens.
So, boss, here is our roadmap for today. We'll start with the big picture of the new standard, unpack ladder diagram, function block diagram, structured text, and SFC, and then wrap it all up with a real-world application. Let's get to it.
Starting right off with Section 1, IEC 2025, the big picture.
So, the crucial update here from the recent May 22nd, 2025 edition 4 release is that there are only 3 official core languages now: ladder diagram, function block diagram, and structured text. Meanwhile, sequential function chart, or SFC, acts strictly as a structuring element. It's not a standalone 4th core language anymore. Oh, and the old instruction list? Yeah, that is officially removed. We are now fully working with a unified suite approach for modern systems. Moving on to Section 2, ladder diagram, the undisputed king of discrete logic.
Whenever you're looking at a process, I want you to permanently anchor this question in your memory. Ask yourself, conditions क्या हैं जिनके basis पर output on-off होगा? If your problem revolves around on-off logic, interlocks, permissives, safety conditions, or just discrete I/O, well, ladder diagram is your immediate no-brainer choice.
Ladder diagram is absolutely brilliant for classic discrete applications. We're talking about your standard motor start and stop logic, complex interlocks, and critical safety circuits like e-stops. For instance, if you need a pump to run only when the start button is pressed, there's water in the tank, and there's no active fault, LD's visual simplicity makes it the absolute best tool for that machine control and, crucially, for rapid troubleshooting by maintenance techs.
And this brilliantly illustrates exactly why LD is so universally loved. You can see how seamlessly a traditional electrical relay schematic maps directly over to PLC ladder logic. It's literally just representing the flow of logical states with contacts and coils. It's instantly familiar to any electrician who needs to jump in and diagnose a fault at 2 a.m.
Now for Section 3, function block diagrams, or FBD, where we shift our focus to signal processing.
When we move to FBD, the trigger question completely changes. Now, you need to be asking, ये signal किस function या block से process होगा? When you are dealing with continuous analog signals, signal processing or process control, this is exactly where your mind needs to go.
FBD is the natural, undeniable choice for analog loops. Think PID temperature and pressure control, analog signal scaling, and complex HVAC or building management systems. Say you need to compare a room temperature to a set point. Feed that error into a PID block, and then output a signal to a cooling valve. FBD visually represents that data flowing smoothly from left to right through interconnected blocks. It's just elegant.
Now, what's really interesting about this setup is how cleanly FBD handles analog parameters compared to traditional ladder rungs. You literally just trace the raw analog inputs going into the scale block on the left and watch the scaled outputs exit on the right. If you tried to do this exact math and ladder diagram, it would result in a bunch of messy, hard-to-read rungs. FBD keeps it visual, clean, and logical. That brings us to Section 4, structured text, or ST, the absolute essential tool for complex algorithms. Whenever you hit a wall with those graphical languages, this is your anchor question. मुझे calculation या algorithm को efficiently express कैसे करना है? If your problem involves complex calculations, heavy data manipulation, or complicated conditional logic, ST is your hero. So ST looks a lot like programming languages such as C or Pascal. It's literally defined as the textual language of the unified suite because it handles heavy math, arrays, and recipe management like an absolute dream. The 2025 standard even includes UTF-8 string manipulation. ST gives you reusable algorithms and native for and while loops that standard graphical logic gates just completely struggle with.
Check out how smoothly a while loop executes here in structured text. Calculating an average from 4 different sensors is just a simple, clean, one-line equation. Loops and complex math like this are native and incredibly simple to write and read in ST. But trying to build this structure cleanly in ladder diagram, it's nearly impossible, and it gets incredibly messy, incredibly fast.
Let's just quickly walk through this data to objectively prove why ST is the superior choice for data manipulation. Look at string concatenation. Very difficult in ladder, totally simple in ST. Array indexing, super cumbersome in ladder, entirely natural in ST. Complex math takes multiple graphical rungs, but is just a single expression here. And loops aren't even available natively in ladder, but they're built right into ST. It all boils down to execution, efficiency, and readability.
Moving to Section 5, SFC, Sequence and State. Remember, SFC is not a competitor to the Big Three, it's the master organizer. So for SFC, your guiding question focuses entirely on the sequence, system abhi kiss state mein hai, or next state kab activate hogi. It's all about the high-level, zoomed-out architecture of your process. Let's move to and see how this builds step by step. SFC visually maps out batch architectures beautifully. You ask, what happens first, second, and third? We start in an idle state. Some condition triggers the filling sequence. Once a level sensor says we're good, it triggers the mixing operation, followed right by the draining process. SFC gives you that brilliant, top-down view of multi-stage operations without getting bogged down in the code itself.
And finally, Section 6, Real-World Application. Let's build a conveyor. So here is how a professional engineer actually stacks all these languages together perfectly in a single unified system. You map the right tool to the right step. For the Start button and Safety OK, we use ladder diagram for that rugged, discrete reliability. For motor starts and sensor detection, ladder or FBD works great. When the conveyor needs to stop at a specific station, we use SFC for that clear state transition. And for any complex tracking or data processing at that station, we deploy structured text. It's a symphony when it all comes together.
So the crucial point is, you never ask which language is the winner. The true mark of a professional automation engineer is looking at a system and asking, what is the problem and what is the most maintainable representation for it? Master LD, FBD, and ST deeply, and use SFC to seamlessly organize them. Apply this mindset in your next project, and you won't just be a coder anymore. You'll be an architect. Thanks for exploring this with us, and keep building.